I've created a free Roblox game template which includes the core systems that every game needs, like player data saving, UI scaling for all devices, a module framework for easily writing and organizing your code, admin commands for easily managing and moderating your game, and some other things as well. Now, I have a 4-part series in which I showed how I created this entire template and I thoroughly explained all of the systems in depth. The series is longer than 4 videos though because I have expanded from the template and create independent game systems like game portals, leader stats formatting, band GUIs, and others as well. This video is meant to be a quick introduction for this series where we quickly go over the most important information about each of the systems. The goal being that I will redirect viewers, possibly like you, to this video who are watching how we create an independent system but have zero understanding of the overall template. And I haven't fully finished editing this video yet, so you're probably going to be watching this video and be thinking, wow, a 20 or 30 minute video is not that quick. Hey, I try to keep it as quick as I possibly could. Now, when it comes to downloading and using this template, it's very simple to do. Go down below in the description of this video and you're going to find a link and it should take you to this Roblox game template page right here. On this page, you should see the play button, but a little bit above the play button and to the right of the game template title, you should see these 3 dots right here. When you click those 3 dots, it should say Edit in Studio. Then if you click Edit in Studio, it should automatically open up Roblox Studio for you. Then after a few seconds, or maybe even a minute, Roblox Studio should load up and this project should be loaded up for you. You'll know that you're in the correct project as long as you see a GUI on the right-hand side of the screen, which looks similar to this. Now that we're inside of Studio, the first thing I want to take a look at is the module framework and how our project is actually structured inside of our Explorer. So let's go ahead and expand the server script service as well as the starter player and then the starter player scripts. Now, inside of the server script service, we have the services folder, and then inside of the starter player scripts, we have the controllers folder. If we expand both of these folders, we can see some module scripts that are stored inside of them. Now, with the services folder, this is where we store most of our scripts which contain our server-side logic. And then in the controllers is where we store our scripts which contain most of the logic for the client side. Now, if we look at the specific type of scripts that are actually stored inside of these folders, these are module scripts. The reason that these are module scripts is because we write all of our logic exclusively inside of module scripts. And the reason for that is because module scripts have advantages over normal scripts, like being able to share code with other scripts. Now, if you're new to scripting, then module scripts might intimidate you, but just keep following along and do not worry. Now, let's go ahead and actually open up the player data service module so that we can take a look at how I structure my module scripts. Now, most of this isn't very important because most of this is pretty standard. Services towards the top of the script, modules that we have to require, the remotes variable, some types. But then we get down to the local and the shared variables, and here is where the big difference is. In every single one of my controllers or services, I create both the local and the shared table. Then, if we look at the very bottom of my module script, I always return the shared variable at the end of this module script. So, any variable or functions that we attach to the shared table are the functions that will be shared with any module script which requires the player data service. But then we have the local table, which I actually store functions inside of as well, like this create leader stats function. And with the local table, these functions are actually only used inside of this script. So anything that's a part of the local table is not going to be shared with other module scripts which require the player data service, for example. But the get state or update state function will be shared with any other scripts which require the player data service. Now, you might think that the local table is unnecessary, but it actually allows us to be much less strict in terms of which line we specifically create functions or variables on. Now, here's a perfect example of where creating a normal local variable is kind of annoying. So I have the remove profile function all the way at the very bottom of my script, and it's actually used towards the very top of my script on line 37. And again, this is a part of the local table. Let's go ahead and create a normal local function like we normally would. So we'll use the local keyword here. Then let's go back up top to where we actually want to use this function and then go ahead and try to call it. Now, when we try to call it, we can see that there's an error here. And the reason for that is because we actually have to create these normal local functions before we use them inside of our script. So I would have to actually create that above the onStart function. And now we see that we are actually able to use the remove profile function. But that's why we actually want to use the local table and where the local table is useful at. Like I said, using the local table makes your scripting organization a little bit easier and a little bit less strict, which can be good or bad. But it's definitely some flexibility that I prefer to have, and that's why I always create a local and a shared table inside of every single module script for both the services and controllers and kind of almost everywhere that I create. Now, another unique thing which is included with the module framework is the onStart function. Inside of any service or controller is where we can create an onStart function, which is a part of the shared table. And any of the logic that's put inside of the onStart function will actually run when your game starts up for the first time. Again, this needs to be a part of the shared table because the module framework needs to access the onStart function from your shared table to be able to call the onStart function to begin when the game loads up for the first time. Now, of course, since this is a part of the shared table, other modules would be able to use the onStart function when you require this module script, but just don't do that. Do not use the onStart function in any other module script because this is automatically called when your game starts up for the first time. So you should never actually call the onStart function ever. And the reason that we prefer the onStart function is because it makes organization so much better. In any service or controller I create, the first function that I create if I need an onStart function is the onStart function. So when I open up my service or controller, I can look at my module script and look at the first function and see, okay, this is all of the logic which runs as soon as my game starts up for the first time. Whereas the usual method for where you would store this code is actually towards the very bottom of your script. You would normally store this all the way down here. But in my opinion, this is a really weird way to organize your code and doesn't feel intuitive at all. Instead, if you store that inside of the onStart function, it makes it very clear as to what this logic is for and what it actually does and when it actually happens. Now, we've only looked at the player data service. You can also look at the GUI controller as well as the state controller to kind of further your understanding of how I write and structure my module scripts. Now, the next system that I want to cover is the player data service. And to begin talking about the player data service, first we want to go inside of the replicated storage and open up the player data module script. Now, this right here is a perfect example of how our player data is actually structured. The variable default player data is the literal default data of what your player has when they join the game for their first time. So when a new player joins my game, they'll start off with 0 coins but have 1,000 gems. And then we see that I have the shared table right here. I don't have a local table because I instead actually use a local variable here, but we still do have our standard shared variable, and I share the default player data variable just like this. So if you ever want to save more information about your player, you would add it to this table. And you would also update the type here, but types are a little bit more complex, so if you don't understand the types, you could kind of just ignore this or literally delete this and then delete that variable. You might have to delete some other locations, but either ignore it or delete it. So that's just how our player data is actually structured. Then let's go over how our player data is being loaded, saved, and sort of managed. And we can do that by looking inside of the server script service. So if we look inside of there, then we look inside of the services folder, we have the player data service, which will once again open up. Now, we load, manage, and save our player data by actually using an open source public library called the Profile Service. The library is extremely reputable, has been used for many years, and is used by a ton of popular games. I'll leave a link down below in the description to learn more about this specifically, but essentially we're using their code, which handles working with the data store service for us entirely. So it really helps us avoid messing anything up and makes saving players' data extremely easy. Okay, so since we're trying to make this a pretty quick video, I'm going to try to get through this pretty quickly. We have a variable called data store name, and this is set to production. If you ever want to wipe all of your players' data that's currently saved in your public production server games, you would modify this string. But you pretty much never would ever want to modify this string, for the most part, unless you literally wanted to wipe all of your player data. Now, if you did change this from, say, production to production 2, or literally just something random, if you ever changed it back to production, the original data that was saved to production will be loaded up once again. So it's not like all the data is permanently erased, you can recover it, just swap back to your previous string. Then we have an if statement, which is in studio. So if the game starts up in studio, this is the data store name that we're actually going to use. So if you ever wanted to wipe your own player data, which you're using to test inside of Roblox Studio, you would change this string. Sometimes I use this after I implement a brand new system or maybe make like a game-breaking change where I need to delete some of my previous data. I'll go ahead and change this, and this will only affect myself inside of Studio. And also, doing this prevents us from actually modifying or working with the production data store, so we avoid possibly ruining or messing up or affecting the player's data that's currently in production on the live servers. Then we have the profiles variable, which is where all of the player's profile is stored when they join the game. So they are stored in key value pairs, the player object being the key, then the profile being the value. Then we have a bindable event, which we call profile loaded, which will be fired off whenever the player's profile is loaded for the first time. So essentially, this is an alternative to the player added event, because sometimes you want to do something when the player has joined the game, but you also need their data to be loaded. So you would hook into this profile loaded event, which is only ever fired off when the player joins the game for the first time and their profile has been loaded, because it could take a couple seconds sometimes when the player's joining the game. Now, if you ever want to access the player's data, you would use this shared function inside of here called getState, which you'll go ahead and pass the player. Now, if you ever hear the word state, state is a synonym for data. So you could literally think of this function as being called getData, but sometimes I refer to data as state or as data. So the getState function just gives you the state. But if you want to ever modify the player state, you would actually use the update state function, which we'll cover shortly, because we actually have to go over the entire state manager and how that works. Now, to abruptly end the player data service explanation there, it kind of ties into what we're talking about now, which is the state manager. And like I said, state is a synonym for data. So we're essentially talking about how we manage the player's data. Now, we actually have to manage the player's data on both the server side and the client side. The server side, of course, is where the player's data is loaded and saved at. And then on the client side, we actually need to replicate the player's data that's all handled on the server side and send that down to the client side so that we have access to that for things like updating GUIs, to display how many coins a player has, or different things like that. Now, to get a better understanding of this, let's go inside the replicated storage. Then we want to go inside of the functions folder and open up the update state module. Now, this module actually contains a single function, as well as a type, which is called state action. And you can see each one of these is an action. So we have 3 different actions here. And then inside of the function, we can actually see the logic which is performed when a specific action is being ran. So if you look at the state action type, each action table here includes a key value pair with the key being action and the value being a string. And this is how we specify the specific action that we're going to perform on the player's data. And we use these inside of this function right here. So the player data service actually uses the update state module script and uses this function right here. And from the player data service, what we do is we pass through the player's current data, and then we also pass through the action that we're going to perform. Now, how we actually would create an action would be something like this. Let's go ahead and create a variable called action. We'll specify the type of it to be state action. We would say equals, then we would go ahead and create a table. Now, first we need to go ahead and specify the action, which we can see are different options for actions right here. Let's go ahead and just say that we want to use the update currency action. We'll then use a comma, and now we need to specify the other parameters which are included inside of this action as well. So we want to specify the currency as well as the amount. So we'll go ahead and say currency, and we can see that as we type this out, this isn't actually suggested to us automatically. But if we were, for instance, to type out the word amount, that is suggested to us automatically. The reason that the word currency is not suggested to us automatically is because currency does not appear in all of these tables. It only appears in one. But amount is suggested to us because amount appears in all of these tables. Now, of course, as you add more actions, amount probably won't appear anymore. So you'll just have to make sure that you kind of either look at the action or make sure that you remember the information that you need to include in each of the different actions. So I'll go ahead and say the amount that I want to give is 10, and the currency that I want to go ahead and give would actually be coins. And there we go. We've now created our action, and then what we would do is just go ahead and call this function, which let's just say, for example, is update state, even though that's not even a function that exists inside of here. Then we would need to go ahead and pass through the player's data, and then we would pass through the action like that. I know it doesn't really exactly make sense, but that's how you would create an action, and that's how this function's actually used. Now, you never actually use the update state module script yourself. What you do is inside of the player data service, we have the update state function. So you would actually call this update state function where you would just pass through the player and then the action, which I just showed you how to create. Because then inside of this function is where the update state module script is actually used at. That function is used to perform the action on the player's data, just like that. And also, taking a look inside of this function, this is how we actually handle using the actions to modify the player's data. So if the action is update gems, then what do we want to do? Well, we would increase the current amount of gems that the player has by the amount key value pair. So that's how we modify the player's data. Now let's talk about how we actually handle replicating the player's data from the server side down to the client side and keeping them in sync. So actually, inside of the update state function, we can see that we use a remote event called update state, which is fired off anytime the player's state is changed. And like I said earlier, the only way that you ever want to affect a player's data is by using this update state function right here. And the reason for that is because this is how we use the actual update state module function. And then we also use the update state remote event in order to replicate the action. So we send the action to the player's client. And then if we actually look inside of the starter player, inside of the start player scripts, inside of the controllers folder, we have the state controller, which inside of here, we actually listen for whenever the update state remote event is fired off. And whenever the update state remote event is fired off, we actually also use the update state module script and use that function to update the current state with that action. So that's how we replicate the changes that we make to a player's data anytime we make a change to their data. We simply replicate the action to the client, and then we also perform the action on the client's data that's already synced with the client. Now, we actually haven't covered how we sync the client with the server. To save us some time, I'm going to skip explaining the full details of this, but essentially when the player joins the game for the first time, And when their data is loaded, the set state remote event will be fired off to the player. So that's how they'll be given their initial data when they join the game. And then anytime we perform a change on their data on the server side, we'll go ahead and also apply that change on the client side right here to keep it in sync. And inside of the state controller, we also have a bindable event here, which is called update state. And with the update state bindable event, it's fired off anytime an action is performed. So whenever it's replicated from the server down to the client, and we often use this when working with GUIs. For example, we actually use this inside of the currency module script, and we listen for the update currency action to be used, and then we go ahead and update the GUIs to reflect the player's current currency. Now, also inside of the state controller, we have the get state function, and this is the function that you should use whenever you want to use the player's data on the client side. So if you want to see how many coins they have, for example, or anything like that, you would go ahead and use the get state function. Now, the next feature of the template I want to talk about is UI scaling. And what is UI scaling? Well, to quickly demonstrate this, let me go ahead and set my device size extremely small and start my game. Once I started my game, we can see that the GUIs are resized to appear differently on my device, and well, they look well suited to my device. So how that actually happens is by this script inside of the starter player scripts called UI Scaler. Now, this script specifically doesn't exactly matter to you, but what actually matters is how we structure and how we create our GUIs. Now, the first thing I want to say is anytime I create a GUI inside of Roblox Studio, I always use the device emulation. The reason that I do that is because this allows me to specify what resolution I'm actually working with, and it allows me to easily maintain that resolution. If you're not using device emulation, your resolution can rapidly change. Also, I like to create my GUIs at 1920 by 1080p, but you can feel free to create them at whatever you like as well. Next, let's take a look inside of Starter GUI, where we already have a screen GUI created for us. Inside of the screen GUI, we have a UI scale object. Now, this UI scale object itself is not very important, but it's actually used by the UI scaling script that we saw inside of the starter player scripts. So that script actually looks for the UI scale object inside of any of the GUIs stored inside of here, and if it sees a UI scale object inside of that GUI, it'll check if it is tagged with scale component, and then it also checks for an attribute on it called base resolution. So let me demonstrate that for you. Let me go ahead and create a brand new UI scale object, which we can see right here. It doesn't have any tags. Then what I want to do is add a tag to it, so I'll click the plus icon, and then I want to go ahead and use the scale component tag, which we can see suggested to us right there. Now that it has that tag, we also want to add an attribute to it as well, so we'll go ahead and click the plus icon right there. We then want to go ahead and create a vector2 attribute, which we'll go ahead and call base underscore resolution. Now that we've added that attribute, we need to specify the resolution at which we created this GUI at. And we can find a resolution by looking right here as to what we emulated our screen to. Maybe for some reason you created this GUI at a very small resolution like 480 by 320. Well, you would go ahead and say 480 by 320. But because I actually created my GUI at 1920 by 1080, I'm going to want to go ahead and specify 1920 by 1080 here, so that the scalar library knows how to correctly scale this GUI up or down. Anyways, I'm going to go ahead and delete one of these UI scales because your GUI only ever needs one. So essentially, anytime you create a brand new screen GUI, go ahead and, set up your entire GUI and create the entire thing. Then what I would recommend that you do is just duplicate the existing UI scale and drag it inside of the screen GUI, and then boom, there you go. As long as you haven't changed your base resolution, then you don't need to change anything about this. Now, some other tips that I'd like to give you to make working with the UI scaler a little bit smoother is for the size, I would call this frame right here like your first frame of your screen GUI, which essentially probably holds all of the other stuff inside of your GUI. This frame, the size of it should actually be set in offset instead of scale. The UI scaler very much prefers offset. Again, like I said, I would call this your core frame. Now, the frames inside of here, you can actually use scale instead of offset, or you can use offset as well. It doesn't really matter. But for this frame right here, which is your sort of primary holder frame, this is very important and it needs to be offset. Otherwise, using scale will prevent this from being scaled up correctly. And also, I would recommend mostly using offset for your sizing for most things, but if you do want to use scale for inner elements, I would call them, you can actually do that. Additionally, your positioning with objects, if we look at the currency frame right here, you should either use only scale, or you should use a mix of scale and offset, which is what we're doing right here. We're using scale, and then we're using a little bit of offset as well. But you want to avoid using only offset because the GUIs will not be automatically repositioned if you're using only offset. Then if we look inside of the coin frame, we have the amount text label, and if we look at the text properties, we can actually see that we're not using the text scaled property. Instead, we actually specify the text size of the text label, and we specify the text as being 30 here. So what I would recommend is that you never use the text scaled property again. Instead, you only ever want to specify the actual text size that you want. And that's pretty much everything that you need to know when it comes to how you should create your UIs to work with the UI scaling library. Now, the next system that we're going to cover, and this is going to be extremely quick, is the admin command system. The core of this can be found inside of the server script service and inside of our CMDR folder. Now, this folder is actually named after the library which we're using to make the entire admin command system work. So we'll leave a link down below in the description to that library if you want to learn more about it as well. Similar to the profile service library, the Commander library is used by a ton of popular games. It's extremely reputable and it's been around for a long time, so that's why we're using it in our projects. Now, we don't even actually create admin commands in every single one of our episodes. That's why we're going to go through this a little bit quickly. But to quickly touch on this, commands are created inside of the commands folder, and they're created by using two separate module scripts. So we can see that we've created one custom command here, which is the adjust player currency command, but there's two module scripts inside of here. One is named adjust player currency, and the other is named adjust player currency server. Let's go ahead and open up both of these. Now, the simple adjust player currency module script is actually used by Commander to understand how the command is set up and how we want it to be created. So this is where we'll do things like specify the name, specify the arguments, the group for permissions, and different things like that. And then in the other module script, which ends with the keyword server, this is where we actually write all the logic which should run when the command is used. So here's where we actually adjust the player's currency inside of the module script, which ends with server. Whereas when we want to create and structure the entire command, we would just write that inside of the normal module script that does not end with the keyword server. Now, another important thing about the Commander library is that you should also look inside of the replicated storage, inside of the configs folder, and open up this Commander module script, because inside of here, we have a table called admins, which currently only contains my own user ID. So what I would recommend that you do is remove my user ID from the admins table and simply add in your own user ID to this admins table. And you can even add in multiple user IDs if you want multiple people to be admins and have the permissions to run the commands for your game. But anyways, ladies and gentlemen, that's going to be it for this episode. As always, if you did enjoy, make sure you smash the like button. Please leave a comment down below letting other people know that it did work. I and they really do appreciate it. It helps everyone out. And as usual, if you want to gain access to all the scripts and the game file that we made during this episode, as well as a ton of other assets, you can visit monster.dev or my Patreon, link down below in the description to both of these. You can gain access to a ton of assets to easily create your next Roblox game, as well as support me in creating all the content that I create. Anyways, with all that being said, I hope that you guys have a great day, and I'll see you guys in the next episode.